So, what you just saw was essentially the game of Plinko. I think I mentioned that somewhere up on here. Yeah, Plinko game results on The Price is Right at OMSI. So, what you see is you see basically a ball dropped at the top of this pegboard, and then the pegs bounce the ball back and forth, essentially randomly left and right. But what you end up having is you have a random distribution at the bottom after all these half lefts and half rights. And just like it's very, very hard in the original distributions back here to end up in the tails over here and the tails over here, because in order to end up in the tails over here, you basically have to keep taking left turns. And in order to end up in the tails over here, you have to basically keep taking right turns. Well, that's not likely, because the probability of a half means that you'll be taking left and right turns essentially with equal frequency. Now, when I say with equal frequency, exactly equal would put you exactly in the middle. Sometimes you're a little heavy to the left or a little heavy to the right, but you're very rarely all left or all right, or even, 10% right and 90% left. You're more likely to fall in the middle. So what you're seeing in all of these types of data is you're actually seeing data that is influenced by many, many, many tiny little variables, much like the balls falling in that OMSI display that my son and my wife were checking out. So egg incubation times for chickens, for example. Think about that. All the influential characteristics that go into an egg and the production of an egg in a chicken. The temperature of the coop, the diet of the bird, the hydration of the bird, the pecking order of the bird. I keep 4 chickens, as you guys know, and I've seen Marge getting picked on by Mary quite a bit. Mary's more aggressive. That would probably influence egg incubation. Okay, the stress level of the birds, how much access to space that they have. Lots of these things are going to have many, many variables influence them. Actual volume of a 15-gallon gas tank in a car. Okay, those are made by a machine, and those machines have tolerances, differences in the metal, differences in the time, differences in the consistency. All those little tiny variables are very much like the pegs that the balls are bouncing off of. So what you end up seeing is you see a distribution that looks like this by the end. On average, most of them fall towards the center, and in rare occurrences, they fall off to one side or the other. And that's what we do quite a bit in 244. We're going to start that study here, but quite a bit in 244 is quantifying that. But more on that to come. For now, what I want to do is I want to show the mathematics of the transition from pure binomial distribution to this beautiful normal distribution.